Alright, good day, student. Today we'll be treating performing function operations. What do we mean by performing function operations? Well, to perform a function operation which involve addition, subtraction, multiplication, and division function. So in order to perform function operation, we add function, we subtract function, we multiply or divide function. So let's proceed. Operations on function. How do we perform operation on function? So let f and g be any two functions. Let f and g be any two given function. A new function can be defined by performing any of the four basic operations on f and g. A new function, this is new, can be created by performing function on f and g. So what does that mean? By these two functions we can create a new function by performing a function on f and g. This function can be addition, it can be subtraction, it can be multiplication or division. So let's see how these functions can be performed on f and g. So to be able to do this, let's clean the board. I hope you are following. We already know what function can be performed on f and g, where f and g is a different function to themselves. So operation, let's create a table of value for simplicity. Examples. Our example will be based on f of x equals to, let's use 7x. I hope you are seeing it. And g of x equals to s plus 4. So let's create a table of value and see how we can perform or create new function using already existing two functions. So the first is addition. So if you add f plus g, adding f plus g, both of which is a function of x, this will give us f of x plus g of x. So when we add the two, in this case f plus g, for example here, see this example, a function of x, so we have 7x plus x plus 4. This will give us 8x plus 4. So a new function is created when we perform operation function on f of x and g of x. So let's go for subtraction. In this case, g subtracted from f, a function of x, is the same as f of x minus g of x. So in this case, f minus g is a function of x. So let's perform a function here. We have 7x minus in bracket x plus 4. So put bracket because minus subtraction sign will affect the terms in the each terms that make up the g of x. So this gives us 7x minus x minus 4. So this gives us 6x minus 4. This is how we can perform function operation on a given two functions already existing so that a new function can be created. So multiplication, also we can create a new function by multiplying two already existing two functions. So from here we have fg, they are function of x. This is equals to f of x times g of x. So here we have f that is function of x times g of x, the function of x. So this will give us what? This will give us 7x times x plus 4. So if you open bracket, you have 7x squared plus 28x. So finally, division. We can also create new function by performing a division. In this case, f over g, both is a function of x. So this will give us what? F of x divided by g of x. So from here we have f over g element of x. This gives us what? 7x divided by x plus 4. So this is how we can perform a function between two given functions f of s and g of x to form a new function. So there are 4 function operations we already treated that enable us to create a new function. So let's proceed. But before we go on, let's touch some few things. The domain, we have to know that the domains of the sum, this is any different things stuck together. The domains of the sum, difference, product. You know what is different? Difference is subtraction, product, and quotient function consists of the s values. Okay, let's do this up. So you have seen how new functions can be created, operation for division and examples. We now go for addition, subtraction, multiplication, and division. So we can stay let's screen some parts. You can always pause the video, go through what we did, so you'll be able to familiarize yourself before we go into familiarize yourself with the content before we go into examples. But there are some points you have to know. The domains of the sum, difference, product, and quotient function. Domains of this consist of the S values that are in the domains of both F and G. Consist of the S values. I hope you are following. Consists of what? The S values that are in the domains of both F and G. In the domains of both F and G. What does that mean? The domains of the sum, difference, product, and quotient function consist of the S values that are in the domains of both F and G, because domains are measured on the S axis, the values of the X, the X, not the Y. So if the domains of F, what this means that the new domain form is defined by the already two existing domains of the two function. So we'll come to that. Additionally, the domain of the quotient does not include S values for which Gx is equals to 0. The domain of the quotient, you know what is the quotient? Quotient, the domain of the quotient does not include the S values for which G of X is equals to 0. Additionally, the quotient does not. We obtain the quotient when we do division, operation on division. Look at it here. This is the division. F divided by G, a function of this, is equals to F of S over G of X. So the domain does not, the quotient does not, this is a quotient, you only obtain quotient in division. Quotient does not include the S values for which G of X. That is, if you include values of X that will make this function undefined, then there is no need for going for division operation. So we have to remove that S value, that value of X that will make this function undefined. That's what this means. Does not include the S values for which G of S equals to 0. Because if G of X is equals to 0, this function will be undefined. So that value of X that will make it equal to 0 is not included. For here, like this one, S is not equal to what? 4. S is not equal to minus 4. Do you understand? That value, every other, in this case, if F of X is a all real number, has a domain of all real number, and G of X has a domain of all real number, in that case we have to exclude minus 4. We can say that the domain of this new function form is all real number except S equal to minus 4, except S equals to minus 4, or all real number when S is not equal to what? When S is not equal to minus 4. Because S is equal to minus 4, this will be minus 4 plus 4, which will give us 0. That is what this is saying. It will make this function undefined. So quotient does not include the S values for which G of S is equals to 0. So we'll do some example for clarification. Let's go on. So let me clean the board and we proceed. So let's solve some examples involving the operations we have created. The examples will be based on F and G, mainly when F is the given function and G may be the inverse or another given function. So adding, subtracting two functions, state the domain of each and then evaluate them. Addition, subtraction, addition and subtraction of two functions, addition and subtraction of two functions f and g. State the domain. This is a domain. The domain of each. State the domain of each function and evaluate them. So this is instruction. Addition and subtraction of two functions f and g. State the domain of each function and evaluate them. So the first example is f4 of x is equals to minus 5. So the first example, let's go for the first example. f4 of x is equals to minus 5, the 40th root of x, and then you are given g of x is equals to 19, the 40th root of what? X. When x, I hope you are following, is equals to 16. So the first is addition. Let's go for addition. This is example f4 plus g. f4 plus g, a function of x, and then evaluate them. So this is the first